Hi everyone, welcome to another session of Mr. Techpathy Tutorials. This is part 7 of Linux device drivers. Today we are going to discuss about kernel modules versus applications. In this session, we'll discuss about differences between kernel modules and applications in brief. Though there are many differences, to keep it simple and to explain in brief, I have handpicked few differences and listed them as topics form, which can be easily remembered and recollected when required. We compare below topics between kernel modules and applications. First topic will be initialization. Here we'll discuss about how the initialization happens in kernel modules and applications. The second topic is which are event driven. Is it kernel modules or applications? Under this topic, we'll discuss if kernel modules are event driven or applications are event driven. And the third topic is about exit procedure in kernel modules or applications. Under this topic, we'll discuss about exit procedure in kernel modules and applications. Coming to the fourth topic, it's the ability to unload a module. Under this topic, we'll discuss about unloading procedure in kernel modules and applications. The fifth topic is the linking stage. Under this, we'll discuss about the linking stage and how it's relevant in kernel modules and applications. The sixth and last topic will be handling faults. Here we'll discuss in brief the way faults are handled in kernel modules and applications. This tutorial covers only brief description of all the topics listed above. This will help us to understand upcoming sessions with ease. Let's start with our first topic of the day. We'll start with the initialization. When we invoke an application, it starts and proceeds ahead till the end. Most small and medium-sized application programs perform a single task from beginning to the end. Take any applications in your PC. They start and run till you end them. Whereas every kernel module registers itself with the kernel in order to serve future requests, and its initialization function terminates immediately. In other words, the task of module installation function is to prepare for later invocations of the module functions when required. Our second topic will be which are event driven. Is it kernel module or applications? Let's see. To understand this in simple way, say if something happens, an event is raised and that should be served. So with our current understanding, do you think that kernel is event driven? Yes. When a kernel module is loaded, it invokes init function, which is hello underscore init, which conveys kernel, here I am, and this is what I can do. It's conveying the kernel, if something occurs, just let me know, I will serve. When kernel module is unloaded, it invokes exit, which is nothing but hello exit in our earlier examples, which conveys kernel, I'm not here anymore. Don't ask me to do anything else. This kind of approach to programming is similar to event-driven programming. But while not all applications are event-driven, each and every kernel module is event-driven. Coming to our next topic, it's exit procedure in kernel modules and applications. I have mentioned earlier, not all applications are event-driven. Imagine we have event-driven application. Major difference between event-driven application and the kernel code is the exit function. When an application terminates, it can be lazy in releasing resources or avoid cleanups altogether. The exit function of a kernel module must be very careful to undo everything, otherwise there is a chance that few pieces remain around until the system is rebooted. Let's slip to our next topic, which is ability to unload a module. Incidentally, the ability to unload a module is one of the features of modularization that you will most appreciate because it helps to cut down development time. You can test successive versions of your new driver without going through the lengthy shutdown or reboot cycle each time. Coming to the applications, you need to either exit it completely or rerun the application. You will not be sure if the memory allocated is deallocated or the task initiated is exited cleanly. It all depends on how you implement the application. The next topic is the linking stage. An application can call functions which it does not define. The linking stage resolves the external references using appropriate library of functions. Printf is one of these callable functions and is defined in libc. A module, on the other hand, is linked only to the kernel and the only functions it can call are the ones exported by the kernel. There are no libraries to link to. This point is very important. Keep in mind that there are no libraries for the kernel modules to link. You may ask about printk. The printk function used in hello.c earlier, for example, is the version of printf defined within the kernel and exported to the modules. It behaves similarly to the original function with a few minor differences. Because no library is linked to kernel modules, source files should never include the usual header files. There are special exceptions like std.h. Only functions that are actually part of the kernel itself may be used in kernel modules. Anything related to the kernel is declared in the headers found in the kernel source tree had to be set up and configured. Most of the relevant headers live in include/linux and include/asm, but other subdirectories of include have been added to the host material associated to specific kernel subsystems. Our last topic is handling faults. Another important difference between kernel programming and application programming is how each environment handles faults. As briefed earlier, segmentation fault is harmless during application development, and a debugger can always be used to trace the error to the problem in the source code. Whereas a kernel fault kills the current process at least, if not the whole system. We see how to trace kernel errors in upcoming slides. Thanks for watching. Don't forget to subscribe and comment. Goodbye for now.